All right, big round of applause for Adel.
Hello, Jordan. So BOS Rocket actually started, I think, what I learned is it started from someone within Talabat. So basically, it's a great thing to see these things come together. First of all, I'm Adel Khalil, and I'm VP engineering for Talabat. Before that, I was with Visita, Doctor Appointment Booking. I think Visita works in Jordan as well. Let's start by how many engineers, like people writing code, full time? Okay. So this won't be very boring as I thought. Okay, this is a bit technical, more toward engineers, but we will stay high level. As I said, part of Delivery Hero Middle East, Talabat, and Visita. You can follow me on Twitter. I'll be posting the slides and few of the links that I stole most of my presentation from, so you can get the source. So basically, what is serverless? First of all, how many of you guys are in the middle of moving from monolithic to microservices? Okay, how many of you like thought serverless, we have to move again? Okay, good. How many of you know the term backend as a service? Okay, good. So basically, backend as a service is a way to use third-party solutions that is hosted, managed by other people. Think of it like Parse. If you remember Parse before Facebook acquisition, it was one of the early backend as a service, backend for mobile and stuff like that. Also, we have like DynamoDB and like many other tools actually as backend as a service. I guess in 2012, when function as a service emerged, it became the serverless architecture favorite design pattern, right? So what we will be doing today is mostly focus on function as a service. You may know Lambda. Anybody use Lambda or Azure Function? Okay, cool. So as Martin Fowler said, like serverless architectures and application design that incorporate third-party backend as a service, or that it include custom code, run managed ephemeral, containers on like platform managed by others. This is actually a Google trend. Show you like for the past 5 years, serverless, how many people like are searching for serverless right now. Okay. So we'll go briefly around architecture, like basically infrastructure evolution, architecture, like serverless versus a whole lot of buzzwords like container, microservices, pass. Should we use it? And we'll try to like cover a few use cases. And finally, we'll take a quick look at function and service vendors. It's very, very high level stuff. So what is like serverless? Basically, it's fully managed. So what you want to do is, for the most part, you want to focus on business logic, focus on delivering stuff to your customer, focusing on experimentation, like we said in the last session and the one before it. So how you do that is to minimize the infrastructure grunt work. It's like more productive to spend time writing actual feature rather than writing like pipelining code, database management code, stuff like that. So basically, this is the promise of serverless. It has been the promise for cloud for a very long time. And we as like globally technology organization, like we move in that path, and we'll see that right now. How it look like? It's functions. Like your unit is a function. For like microservices, like containers, your unit was a service or a business capability. For serverless or function as a service, your unit is a function that takes like parameters and do something with it. And how you do that? You just like zip code your C#, Node.js, and upload them. Like many of the providers, like major one, GCP, Microsoft, and AWS, actually support lots of languages. We'll take a look at this later as well. So how's this difference as well? Basically, it's much more easier to scale. It's request-based scaling. And obviously it triggers by event, and we spend a lot of time there. And this is the most important part, it's consumption billing. That means if you write something that nobody uses, you don't have to pay for it. Unless you can manage to do like scaling to zero on other infrastructure options, this is the way to go. You can write your code, host your code, everything for free. The first user, you will start paying. Otherwise, nothing, zero. This is very compelling, especially for like you. How often you write jobs that run like once a day, once a month, once every, like ETL jobs, like moving data from somewhere to somewhere else, and you pay for that server. Now, you don't have to. Like, you just can go to serverless and implement it in this design pattern, and you will only pay when you use these logics, when you execute. So, how exactly like cloud evolution for infrastructure started? Basically, this on-premise, we've all built there. Maybe some of us like came a little bit sooner. Afterwards, in hosting, like some of the managed hosting take care of the servers, networking, routing, data centers, stuff like that. Like maybe even physical security and stuff like this. And when you talk infrastructure as service, we do like provisioning, visualization, virtualization servers, network, and data center. That's all taken care of by the third party. And we somehow do like patching for the OS. Like you can rent an EC2 from Amazon, for example, or a machine from Azure, and you do your patching yourself or setup or do OS or stuff like that. With serverless, you only like focusing on the application and some of the configuration. So basically all of this blue is taken care of. You need now to like just focus on the important parts. And this actually, if you look at this graph, it's basically saying you lose a little bit of control over your stack once you move this way, but you actually gain a lot of productivity. You don't have to take care of these servers, manage them, install them. There's statistics that I think, well, I will tweet this one. But basically, I think McKinsey was involved, like 60% of enterprise servers are sitting idle. Like just throwing money. Nobody used them. So you try to move this way, you save some costs, and maybe you lose some control over a stack if that's important. It typically will differ based on the use case. Okay, so now we are done with the infrastructure part, like how to do proper serverless. So to understand, serverless is basically, as we said, like it's scale based on request, right? So it's very important to have these functions stateless. It shouldn't hold any data. It shouldn't know about data in other processes. So you design it like, and most of the people, I guess now, as a good practice, you design your processes as stateless processes. So you can store your session maybe in a database or something like that. All problems comes from storing these data within the process itself when it comes to scaling. So this is a best practice, but actually here it's a very important thing. The other thing is event-driven. So basically how these function actually triggered. Basically most of these implementation, like we see in Lambda, is triggered based on cloud native event. Like request to API gateway, or a message in a queue, or file upload to S3. All these event triggers whatever function we want. And the idea is how to orchestrate your application or design it in a way that you can make use of these native event channeling and marshalling. And the third thing is it's ephemeral. So basically it have a limited lifetime. Most of them around 5 minutes. Google, I think 9 minutes, something like this. So you need to design your like functions in a way that it executes and exits probably within that limit. Other limitation like memory and disk as well applies. But when we go through the use cases, you'll understand more about how actually we can use something like this. Like how this can be beneficial even with these limitations. Which is actually, I think, more of a feature if you look at it. It should be single purpose. Obviously, you can't do a lot of stuff in these Lambda. So you can like have one function and do something and the other function take over. So single purpose, it will serve you well when you need to like scaling. When you try to separate your functions, this is actually, we get a lot of requests for this one. So we can scale this one independently than the other. And all communication obviously is event-based, so it's asynchronous. So this example show you like a very simplified server container type of architecture. And as you see, like search and catalog have shared memory. They are in the same Docker container or whatever. And if you have lots of maybe calls on search or calls on catalog, you can't scale any one of them independently. That goes as a good practice for like many other architecture style, but especially important here. So what we can see now, if we design this in a more of a serverless way, think about these orange boxes as more of a Lambda function or Azure function or something like that, like function as a service. Here, user like could do a request to the gateway. This request like goes to either identity, search, catalog, something like this. And you can, not you can, actually, with the configuration, without you doing anything in real time, whatever platform you choose, like AWS or Azure or GCP, will fire a lot of lambdas in parallel, or a lot of function in parallel, to actually accommodate your request and then shrink them back even to 0 if no one is requesting your function. So this type of segregation for function actually very helpful here as well. Okay, we can talk about the other thing later. Like all other architectures, especially distributed ones, Lambda, there's nothing like free lunch, right? So basically it comes with some of the complexity regarding security and testing. So basically you have increased surface area, nothing running the same process. It's a bit harder to visualize your system in your head, and we'll see that as use cases as well. So the attack vector, attack surface increases. You have lots of function, lots of queues, lots of databases as well. Same as when you do microservice architecture, but we here take it a little bit further as well. Not only like the surface increases, it becomes more complex. Like you have to think about things like how to test these functions, how to deploy them, how to do versioning, how to do proper security. Another thing, like still what we have today in terms of serverless and function as a service from the platform is not quite there from testability perspective. So we can't like easily run static analysis tool, for example, run these test cases. It's not that obvious. We don't even know how to do it. Like developer needs to learn a lot about how to tackle these regular software development issues with serverless that we have learned how to do it maybe in monolithic application, container or microservices. So a lot of learning here as well. Now, okay. So what good about it? Basically, you reduce operational cost. Think about all the time you've spent maybe from the beginning, like requesting servers, purchasing servers, and installing these servers. Even on cloud, you are asking some system admin to provision these services for you, or you do it yourself. This is actually drop the cost more to close to actually the cost of building this code or writing this code as well. So basically operational cost, development cost, and automatic scaling. You don't have to think a lot about how to scale your systems. It's actually request-based scaling. It's very easy to actually to DDoS yourself as well. So you have to take care of the configuration first, but after that, it's super easy to get high volume of requests. Three problems here basically, like vendor lock-in. Like if you write function in Lambda, it's not easy to move it in like Azure or GCP or otherwise. The problem is when you look at every vendor and how much like they supporting C#, they supporting Node.js, they supporting all sorts of languages. But the problem is you also get tied to some of the SDKs that they are doing. You also tied in the event-driven architecture. You are relying on cloud events that you have to replicate elsewhere. So if your function run because an S3 bucket have like fire event, like file uploaded or something like this, you have to redo this in Azure or GCP in a slightly different way. So it's not super portable. Control, like vendor control as well. So basically, a lot of problem comes with what type of SDK they are supporting. Are they supporting .NET Core 2.1 or 2.2? How long will they take to support 2.2? So you don't have the flexibility as we see earlier that you just like, I will write this one, I've tested this, I will put it in my server or my container and I'm good to go. vendor control that part of stuff. Debuggability is actually like a lot harder in serverless, but again, with simple functions, single purpose ones, very focused, wanted to do just one thing, you can like overcome some of these issues. So should you use it? This is a question, like we've seen the good and the bad, but actually like for microservices, the problem always, like the question I get asked a lot is what's the boundary of microservice? How large it is? How large is too large, right? How small is too small for microservice? For serverless, my thinking is, the problem is, should I use it? Should I use it for everything? What kind of use cases that I actually will get benefit from this architecture side? So basically you can take a look at these 5 things. You need something quick. Maybe you do a prototyping some feature, proof of concept, something like this. It's easily isolated. This function is easily isolated outside of your system. So something like basically sending email, doing some calling an external API, something that you can isolate from your system and it still functions. You don't have a lot of dependency on other parts. Obviously, one action per function. Frequency, you change this function a lot, like you do experimentation. It's like serverless is one of the great things to do experimentation with, because you just can change the logic over and over and over again and scale it and downscale it without too much of infrastructure work, and change the core at different rates, which basically seem, if you have a function, if you have like some kind of business capability, you can divide this into 5 functions, for example. One of them, you usually change this one, and the other are more stable. This actually fits a lot into the serverless model, because you can deploy this alone. Again, more of a evolution of microservices as well. So this graph shows you exactly from economical perspective if it makes sense to use functions as a service or not. So imagine this is the provision server, right? We have like 100% capacity. And we have, this is actual traffic, and we have like a couple of spikes there. So if you actually want to look at it from this perspective, if you have more of a normal traffic distribution, you always hit like this kind of request and load. It's actually much cheaper, not much, like it's actually cheaper to run your own servers, or maybe your cloud servers. If you have like really irregular traffic, you get spikes, and then you can go for hours maybe, or minutes, or whatever, depends on your workload, without any load. It actually makes sense that you go to functions as a service, because you don't have to pay when these servers are idle, in this case. Okay, so basically we'll go around like three examples, like 3 like things that people usually get confused. Function as service is executing only at the reaction to event, execution duration for a limited time, resources like memory and disk space are also limited and vendor controlled. Each function reflects a small capability, like we said, like processing messages, handling single requests, stuff like that. For backend as a service, vendor provide the maintainer and provided and maintained. Server-side logic, internal stuff like Gateway, DynamoDB, Firebase, because a lot of people use Firebase. If you look at it from platform as a service perspective, vendor manage provisioning, scaling, runtime, stuff like that, but you have to manage all the things from OS and up. You manage application, operating system, you manage application servers like IIS, Apache, stuff like that. And okay, and we'll look also about microservices, which is like the most confusion. Microservices is actually architecture style, but not tied very well with infrastructure. Usually you do microservices inside container. You don't have to do that. It's a good idea, but they are 2 separate things. So if you do microservice in a container, mostly it's running all the time. Each microservice should reflect business-like feature, like a whole payment, like order management, stuff like that, where functions is a much more smaller in scope. Okay, so 2 use cases, like if this is like serverless, it has like a lot of problems, have a lot of benefits, it have cost savings, but it's actually sometimes cumbersome to deploy and manage and do operation with. So how can I use this, like get the best benefit? Imagine this scenario. We'll go like on a several use cases, and we'll try to allow some time for questions later if we can manage to do that. Imagine, like, I know like a lot of people, like maybe 100% of you guys have some sort of automated report that sends sales numbers, sends stuff like that at the end of the day, or maybe end of the week and end of the month. A good candidate for serverless, like you can have a CloudWatch scheduler or any other something that can trigger an event on a specific time, like 12 a.m. every day. And this one will actually trigger our function, which can go query the data store and then call an SNS or SES service to send an email. All of these things, if you consider this data store is actually DynamoDB and this is SES, we won't pay anything for the entire day, apart from some cost for the data itself, only for the few minutes that this report will query the database and then number of emails that we will send. So this is a good example. If you look at it, it's actually two actions. We can segregate those, but it's focused, single purpose. We don't use it a lot. Like if you think of it from traffic perspective, this is a request that triggered once a day, so you don't have a full server for it. Another example is log analysis, and this is actually quite a very good example. Like I encourage you guys to look at it from this perspective and implement this at your company as well. So who has time to like read logs? Like you always read logs after something actually happened, and you go through these logs and trying to figure out what was the problem actually, if we can think of something happened here, if you can search for this particular keyword. What you can do is have your logs shipped to S3, for example. Once the file is S3, you can process this in duration, like every 10 minutes, 5 minutes, or once a file is uploaded. So once you ship these logs, you can do some analysis in Lambda. You know that where your system breaks. You can transform these files, read into them, search for specific keywords, specific component, stuff like you are logging these stuff, so you know when actually it will break, or maybe you know the reasons behind it. You can do some analysis, like store it in data store like Elasticsearch or something like that for further analysis, but you can actually get notifications right away if the log contains something, well before your application crash or your functionality degraded, and you have to go into the logs to understand that, okay, then now we have requests that taken this amount of time, or we have external requests or something not quite right. With this in mind, a lot of things that you can do directly, like in CloudWatch and these kind of tools, but there's a lot of custom things that we do, and we need actually to write specific code to alert us if it finds some specific pattern code. And this is a great way to implement it. Okay, another this is actually like the most famous example to do function as a service. User maybe upload an image and you want to generate thumbnail, you want to resize it, you want to do some kind of watermarking on it, and then you'll push it to another cloud storage. So this is exactly fitting in this situation as well. This is actually another more advanced use case. When you do ETL, there's a lot of systems, specifically when you guys moving from microservices, from monolithic to microservices, a lot of things, a lot of time you find yourself building these data pipelines that move data from the old monolithic large database to another like disrupted microservices, small databases, well designed, will have like their boundaries defined and stuff like that. And good way to do it is to implement these. You can implement these with like commercial tools, you can implement it yourself, but if you do it yourself, a great way to do it is, again, function as a service. Great example on how you can, once the file in the bucket, you can do validation with a function, and then you can orchestrate your whole workflow. Like you do the validation, you do the transformation, you can directly like move these data into warehouse or use something like MapReduce or something like this, and move this to transformed data. Every step of the way, you control exactly 100% of the logic that goes into the extraction, transformation, and loading. And what is the good thing about this? You'll only get billed when you actually have data you want to transfer. So you can do, and actually you can, one of the other things you can tune actually how much data do I need, whatever happened in the monolithic database right away here, or I can wait. So I can spin like 10,000 lambdas or functions that read this data and transform it and put it in my microservice databases, or I can like just have a couple of them and I wait. So you have a lot of control over how these things can work. Another good example actually is how to build like a website, simple website, on top of serverless, only without 0 servers. You can, for example, when you have a website, like simple website, like HTML, CSS, JavaScript, and stuff like that. So you have all of these things in a maybe bucket or cloud storage that's connected to content delivery network. So that is your front end part. And when you have like more of a dynamic content generation that you want to do, you can directly also from your JavaScript call the API gateway that will fire maybe view post, comment on post, stuff like that. And it will update the content directly on the cloud storage on the store. This you can, if you have very, very simple website or like contact form or maybe marketing website, stuff like that, and you need a little bit of functionality, you don't have to spend an entire server and worry about all those things and scaling and stuff like that. This is like a great way to utilize function as a service to do something like this. Okay. This is actually my last example here, but I don't like this example a lot. But basically, I put this example here just to show you that you can do more with serverless. It's not like you are doing very small parts, like you can do like larger applications with it. You can do that for sure. This is a simplified e-commerce app where you can order stuff and you get like notification for delivery and payment and stuff like that. I'll go through it. But the idea from this is to show you that you can do a lot, but also that serverless is not like replacement for other architecture pattern. You can do microservices for parts that make sense, and you can do serverless. So here in this example, we basically have our user, our authentication backend as service that can be OAuth, for example. We also have our bucket, like for the last example, we did have all of our front end hosted here. If you look, we have inventory management, we have retail management. So I'll focus on 3 actually sections, okay? The first one here is actually the merchant itself. So you can have the merchant calling gateway here, API gateway that channel its request to the retail management system that's based on another API gateway lambda that will do like creating product, another lambda for like setting prices, updating inventory, stuff like that. And you can also channel some of the changes from your administration, like the people who are working on the website content from your company as well, to the same thing, and communicate between those 2 systems with like message queues, SQS for example, also something that you don't have to pay for unless you are using. The idea here that I want to stress on that these can be like microservice for order management or retail management and all these stuff, but for the smaller part, the single purpose part, the stuff that you want to scale, the stuff that you won't use always, the stuff that frequently changes, stuff like that, like we said, you can use that as a serverless. So important message, serverless is not like a replacement for microservice. It's not like the next thing that we have to do. It's a good thing that we should utilize where it makes sense because it will be much better than microservice, specific use case. If you look here, actually, the other party that I want to talk about is actually order management system, and this system is comprised of a lot of small function as a services. Stuff for product listing, imagine every single orange box from this can be 1 or more function as a service. The way this architecture also appealing is it unlocks 2 things. You can have lots of people working productively on these well-separated business capabilities, as well as you can, of course, scale them apart. So maybe online tracking, gaining some traffic, but price listing is not so much. The last thing here I want to talk about is like how you can push notification onto queue or something, and this will trigger Lambda that will actually call the external payment gateway. And this is a great example. We all like integrate with lots of payment gateway. Maybe every product has 2 or 3, depending on the market that you are working on and stuff like that. And a great way to always can change these things, update their code, and they are not dependent on the other application. So Lambda makes sense here as well. So basically, the vendors. So there's lots of them, like IBM has some stuff as well, and a lot of other smaller companies, but these are like the big 3 or 4. You have your AWS, Node.js, Python, Java, C#, Ruby, Go, and PowerShell. These are languages that you can use to actually write code in Lambda. Write code in Lambda. Amazon gave you like 5 minutes per 100 accounts, and you can unlock that. So you can like call support and tell them you need to lift that ceiling. But the minutes, the 5 minutes is not. You can't control the 5 minutes. And the pricing almost all the same. Basically, it's 0.2 per million execution. And if you look at Azure function, it have like you can do bash and batch as well. You can do JavaScript. Amazon, you can do JavaScript as well. So mostly like Azure and Amazon is very well like each other in terms of language support and in terms of limits as well. Google actually limit at 9 minutes, but there's a lot of differences, and it's specifically to your use case. So I encourage you, if you want to do this and you have a high volume, you can go like there's lots of documentation and calculator that you can exactly know if you are looking purely on economic value, where exactly will you be spending. Because sometimes Amazon will be much cheaper, sometimes Azure will be much cheaper. So it's very heavily dependent on the use case. Thanks, guys. If you have any questions, we still have like 10 minutes or so.
All right. Thank you very much, Adel, once again.
Thanks, man.
Great having you. All right. So some questions from the crowd. Do we have the mics around? Yes. I can't see very well. Does anybody? Can you raise your hand? Does anyone have a question? All right, maybe you can tell us, Adel, about your transition from...
This one there.
Thank you.
This one.
All right.
Sure.
But I also had a question about the changing from managing a startup, which is much smaller, being Visita perhaps,
yes,
to going to a delivery hero, multi-billion-dollar company like, you know...
lots of change.
Yeah.
One of the things actually with Talabat and delivery hero in general is, unlike like most of much larger company, we still can move fast. Maybe not fast as like 10, 15, maybe 20, 30% team, but we can actually move that. And the way we do that is basically do, I don't know if you know about OKRs and goal setting and stuff like that, but we know we do all these stuff bottom up. So squads can, they have like our main strategy and the Middle East strategy as well, and that's it. And they should come up with their goals that align with their mission to actually serve these strategic values. So each of these guys, like these squads with themselves, present their OKRs like, we are gonna do this to help in the expansion strategy, and I'm gonna do this to help for affordability and stuff like that.
Right.
And that's how you manage like
so lots of planning from the bottom up.
Yeah,
excellent.
Bottom up. So I can hear you can repeat the question.
I just wanted to ask about the performance aspect of serverless applications, like the lunchtime of the serverless application. I have heard like there are people who are trying to solve this problem by keeping it alive all the time, trigger it like every 5 minutes to keep it alive, so there will be no downtime for it. The lunchtime is that really bad?
People doing this, yeah. But again, I said like serverless or function as service is not like replacement for other things. So if you have this problem, you maybe will suit it to another architecture style. But having that said, also like there is a warm-up time that your function, which is like around 5 to 10 seconds, something like this, like the worst will be 7 to 10 seconds. But what you can do actually is try to do some stuff yourself to try to push these limits further down. So basically, don't download a lot of packages. Don't do like more complicated stuff that stays in memory, so you have to initialize it first. Stuff like that. But exactly as I said, like if you look at the use cases, it's heavily dependent on this if you choose serverless or not. So this is something to think about when you. Any other questions? Yeah.
We have a question back. Okay, we have one here on the left.
Hello.
Hello.
Hello. Here.
Yep. Stand up.
Okay.
Stand up and.
Thanks a lot for the talk. I just had a question. Have you ever experienced the case where you had to go the other way back from serverless to microservices? And what was the case?
Well, not in particular, but the problem is if you fail to. This question goes into how you divide and specifically follow the rules for serverless. Like if you go ahead and back lots of logic in some of these functions, you will sometimes get along that actually we need to build this back and put it on a container or something like this, or we have to go and break all of these functionality into several functions, which takes a lot of work. So if you start with the right mindset, you probably won't end up in this situation, but other than that, you'll be fine. Any other questions?
Yes, there's a question back up there.
There is one here.
Thank you. My name is Shadi from IUMED. I have a question regarding if I am already have a, let's say like a solution and I need to move it to serverless application, and what is, if based on your experience, do you have any, let's say like experience on the time and the effort is needed to move the normal application from normal deployment to the serverless as a development, also as a development effort?
Yeah, it's a lot. Well, the way I think about it, when you do like any kind of refactoring, you should basically refactor as you go, so no big bang changes. Don't spend like 1 year writing serverless application and then, yalla, let's go move everything here. I've never seen this work in my life. But specifically for serverless, I think what you want to do is try to figure out which parts of your system is a good candidate for serverless. Like you can go through all of these things that we did. Like, do you change it frequently? Can it be isolated? Does it have like very hard coupling with your system? If it if you find a good candidate that satisfies all these conditions, maybe this is a good way to start with. So once you get like a request for feature changes or a lot of work into this specific feature, you can go ahead and let's say, I will build this in serverless. It's actually a good candidate. It satisfies all the, maybe the checklist or something like this, and you'll be fine, I guess. Yeah.
Excellent. We have time for one last question.
Okay. Hi. Now, I understand that functions are managed. Now, the question is about the underlying mechanisms that happen that support the scalability aspect. Now, for example, when you have a function that involves data inquiry, such as like something that would check the stock in an inventory, right? Okay. Now, the question is, how can you scale? I mean, the platform would spin off multiple instances of the same function, right? But all of these instances would still be dependent on the same data. So to ensure that you don't face an integrity issue, a data integrity issue, so what happens exactly on those platforms?
Yeah, this is actually a great question, because the problem is a lot of people see that you can spin like 1,000 functions and they're all hitting the same database. It have to do with the type of data store you are using. So if you are using something like again, something serverless like DynamoDB, you can configure its throughput and it can handle and spin another instances to serve your request. So it's like can match the load that is coming from Lambda. If you are going after more of a traditional like database, you can regulate your throughput by using maybe queues, stuff like that, or actually limiting the number of Lambda functions that you can scale to. So you have to regulate it. If you go full like have function as a service, maybe Dynamo or some equivalent, you don't have a problem with this regard, because it will automatically match the load that you are sending it, and you can adjust this throughput from DynamoDB itself. But again, if you're going to traditional database, you need to do your load testing to know exactly what's your limit for the database server. And if you still like need to send the same traffic at the same time, you can regulate it with queues or some other mechanism.
Any more questions? We are lucky that we have time. So if anybody wanted to ask a question, now's the time to do that. No? Yes? Sorry, okay. Stand up, please.
Raise,
okay, back
one.
in the back.
Okay.
Okay, so since this is the pay will be by the use, is there a way to manage and control, like for example, if hacker can go ahead and keep calling your service, and this will eventually increase?
Of course, you can. Yeah, like you can DDoS yourself if you let these configurations running. But you can do all sorts of things. Like for many of the examples that you have seen, we have an API gateway and on top of these things. So basically, let's like back up a little. There you can use Lambda for the front-facing stuff or function as service in general, or you can use it like for the internal stuff. And the most use cases for the internal stuff. If you use it for like customer-facing or user-facing, you have your API gateway with all the security policies and like detection for the whatever threats that you are worried about. But if you have it for the like internal stuff, you have your VPC. There is all sorts of ways that you can mitigate these risks. But if you didn't configure it by yourself, actually, you don't get that automatically. You can actually what you said can happen. You can have someone fire lots of requests as you and drain you basically. But there's the tools in place to protect you from this. The pattern is like API gateway for anything HTTP. And the other stuff, you need to protect your whole like infrastructure with a VPC or something. It's quite easy, so no worries there.
Excellent.
Any other questions?
We have one here. Yazan?
What do you think about setting something up like OpenFaaS while still managing your own servers? So you have the platform for functions as a service.
Well, yeah. OpenFaaS, for the people who doesn't know, like is the function as a service or Lambda equivalent, but open source, and you can host it yourself. I think like unless you have a massive developers like organization, I actually don't see how you can get the value out of this. Maybe for security reason, for like specific type of application or regulation, you need to do these kind of stuff. But other than that, if you don't bound by these regulation or security or stuff like that, unless you have like a massive number of developers working on something, I don't see how it will, the people you will be spending like configuring OpenFaaS and doing the maintenance and system admin and stuff like that, you can't offset this cost unless you have large number of people using.
Fantastic. Well, we have a coffee break now, and we'll be able to actually chat one-on-one with Adel. Thank you very much for being with us.